Night diving. In this module, you will learn what factors characterize a night dive, discover important safety precautions regarding night diving, learn about the most suitable equipment for night diving and how to use it, learn the main light signals and find out how to prepare for a night dive correctly. Diving at night. Night diving is a fascinating and distinct aspect of diving. Many animals that are active during the day go to sleep, while, as if from nowhere, the nocturnal species appear. Areas that by day may seem deserted explode with life at night. Every square centimetre, inch of the rocks and boulders swarms with activity. In the beam of the dive light, the colours appear bright and luminescent and seem more intense due to the lack of sunlight. The risks involved in night diving are not very different from those for daytime activities. In effect, the difference is seeing well only the things that are illuminated by our dive lights. So, there is the possibility of bumping into rocks or animals, or having difficulty finding your BC commands. Remember that one hand will be occupied with holding the dive light, and so you will only have one hand to do everything else. The dangers are fewer than you think. No ferocious predator will tear you to pieces, and monsters will not appear out of the darkness. In reality, the only things that will be astonished are the fish, surprised by the unexpected light. An extremely important safety precaution is that you always stay outside any type of enclosed environment, such as caves or wrecks. Not being able to see the illuminated exit means that you could easily get lost, so avoid going into any sort of cavity at night, even if it seems large. The main danger is that the darkness provokes an increase of stress, which must be dealt with to prevent panic arising. Equipment. As well as all the standard equipment, you must have a good source of light. In order to read your instruments easily, the display should be phosphorescent, or better still, with a backlight. In this case, it is also easier to locate them on the dive. Individual or buddy pair identification lights are also used on night dives. In some areas, these lights are even imposed by local regulations. The most common are chemical lights. These are small plastic tubes containing two separate chemical elements, which, when they come into contact with one another, produce a chemical reaction that creates light but not heat. The chemical lights are attached to the equipment so that they are clearly visible during the dive. You can also get them in different colors, enabling you to identify a diver or buddy pair even from a distance. It is best to get information about the local regulations for their use. In some areas of the world, it is forbidden to use chemical lights for diving because the chemical substances they contain could pollute the environment. For this reason, there are small lights of similar dimensions on the market, but which are powered by batteries. A useful safety tip is to use reflective strips or details on your BC, so you can easily be seen underwater or on the surface. You should also always carry some kind of acoustic device for use on the surface. Because it is difficult to communicate in the dark, use a phosphorescent dive slate so you can communicate more easily without being blinded by the light of the diver who wants to signal something to you. The dive light. The external dimensions of a dive light are no longer an indication of the strength of the light or the autonomy of the battery, and even very small dive lights can produce a very powerful light. As size is no longer a determining factor, we must look at the different features of a dive light in more detail. In the first place, a dive light must be suitable to take underwater. Watertight flashlights, both waterproof and water-resistant, are not suitable for night diving. To make a night dive safely, you need a main dive light of average strength and autonomy sufficient for a normal dive, between 30 minutes and an hour. A spare light is advisable, even though not a necessity. It should be small enough to put in your BC pocket or attached to the ring on the shoulder strap. A very useful light is a strobe, which can be attached to the ascent line a few meters, feet from the bottom. To have a powerful dive light with a long autonomy, you should choose a model with a separate battery pack. One of the essential features of a dive light is the type of handle. Small and medium-sized lights are usually held along the casing, while the larger ones have a carrying handle. It might be necessary to use both hands on the dive, so it is important that the dive light has a cord attached to it for safety, fitted with a toggle and even a carabine hook. So you have both hands free, you can use lights fitted to a helmet or the mask strap. However, in this case, it is impossible to look at another diver without blinding them. The switch can be mechanical or magnetic. The mechanical system has the disadvantage of having a hole through which the controls pass, a delicate point that is subject to leaks and electrogalvanic erosion. Instead, the magnetic system is more watertight. The switching occurs with the movement of a magnet outside the casing, near a small internal switch called a reed bulb, which is sensitive to magnetic fields. The crucial factor in the choice of a dive light is the strength of the light. Usually, the strength indicated by manufacturers, for example 20 watt, refers to the electricity absorbed, but this has little to do with the actual luminosity of the light. In fact, by changing the type of bulb, you can get more light even with a lower electrical power, as occurs with discharge lamps. To improve things, some companies have begun to indicate the strength in lumens, unit of luminous flux. This table lets us make a quick comparison between the absorbed power and the luminous flux generated. Other companies have begun to use the term lux, which expresses the quantity of luminous flux on a unit of surface area. It therefore depends on the distance from which the measurement is taken. A light strength equal to traditional 20 watt and 35 watt bulbs is more than sufficient for main dive lights, while 50 watts and 100 watts are strengths more suited to the dive lights used by guides or as lighting for videos. Instead, it is best to choose spare dive lights for their small size and limited strength, while favoring a reasonable autonomy. The main dive light should have a fairly wide beam, while the spare one should be narrower. Traditional light bulbs, the incandescent type, are made up of a filament enclosed in an empty glass bulb. As the current passes through the filament, it gets hot and becomes incandescent and gives off light. These bulbs have three substantial defects. Most of the electrical power absorbed is wasted in heat. The hot filament is particularly fragile. The light it emits, in respect to sunlight, is redder. To avoid this predominance of red, you can slightly increase the power at which the bulb functions. It is said to be overvolted. The light is whiter, but the bulb will be hotter and will not last as long. Another way of getting a whiter light is to use a halogenous lamp. Its structure is similar to that of a classic incandescent bulb, only that the bulb is filled with halogenous gas. Other types of bulbs are HID, which stands for high-intensity discharge. Light is obtained without the use of a filament by electrifying the ions of xenon gas until an electric arc of great light intensity is produced. At an equal value of electrical strength absorbed, they are 6 times brighter than halogenous bulbs. They also have 5 times greater autonomy and emit a bluer light. In order to work, they need an electronic control unit that raises the tension of the batteries up to the 25,000 volts needed to start up the electric arc. They are not suitable to being repeatedly turned on and off, because the light is dim and yellowish as soon as it is switched on and then only gradually emits a brighter white light. Instead of a bulb, you can use LEDs, light-emitting diodes. These are efficient because they give off no heat, and the light they emit can also be very similar to that of sunlight. The safety switch is an accessory that is becoming more common on dive lights. With today's powerful and compact dive lights, there is the possibility that if a dive light gets switched on accidentally in a dive bag, the light itself could be damaged, as well as the other items it is in contact with. If the dive light doesn't have a safety switch, it is advisable to take out or disconnect the batteries, or remove the bulb. This precaution is also requested by many airline companies before dive lights are allowed on board. Batteries. There are 2 main types of batteries for dive lights: disposable or rechargeable. Disposable batteries can be of the zinc-carbon type or alkaline, with a nominal tension of 1.5 volts. The difference between zinc-carbon batteries and alkaline ones is the amount of current they supply. The voltage in zinc-carbon batteries drops rapidly and continuously and is almost linear. Instead, the voltage in alkaline batteries stays more or less constant, then falls rapidly. Recently, lithium 3.6-volt batteries have also come onto the market and are the best available at the moment. There are also rechargeable accumulators. These can be lead, nickel-cadmium, or nickel metal hydrate. Most rechargeable batteries are subject to running down, even when they are not in use. They become damaged if they reach the minimum level of charge. This is why some lamps have a low tension alarm, or even an electronic display that shows the charge state of the battery. Nickel-cadmium batteries suffer less from the disadvantage of running down. They can sustain more cycles of charge, discharge, and are stronger. However, their average tension is 1.2 volts per element. This means that replacing the 4 disposable batteries with 4 rechargeable ones of the same size, the lamp will no longer be supplied with the required 6 volts, 4 by 1.5 volts, but just 4.8 volts, 4 by 1.2 volts. A great defect of nickel-cadmium batteries is the memory effect. In the case that the charge of the battery is only partially used, after a few cycles, the accumulator memorizes the intermediate value as if it were the minimum, and the lamp turns itself off when it reaches this level. Because the memory effect is due to the cadmium, Nickel metal hydrate (NiMH) batteries have been developed in which the memory effect has been almost totally eliminated. The problem with these batteries is that during prolonged charging they may produce explosive gases, mainly hydrogen. This is why some manufacturers fit their dive lights with a safety valve. Caring for your dive light. A weak point of dive lights are the seals, the so-called O-rings. If subject to pressure over a long period of time, they deform, reducing their ability to keep out the water. This is why it is best to keep dive lights partially open or take out the O-rings if they are not being used for a long time. This will help the O-rings to deform less and so provide a better and longer-lasting seal. Remember to recharge the battery pack before putting the dive light away. Repeat this at intervals if the dive light is not used for a long time. If you have to handle the bulb, take care not to touch it with your fingers. Dirt and grease encourage breakage. Rinse the dive light well after every dive. If the dive light floods, don't dry the salt water, but flood the light completely with fresh water, or better still, distilled water. Remove the O-rings and rinse them in a mixture of distilled water and isopropylic alcohol. Dry it, then spray all the electrical components with a special protective spray, grease the O-rings and reassemble the dive light. If the electrical circuits are flooded, they are almost certainly damaged, and you will have to send the dive light to an authorized service center. Night signals. You can communicate using hand signals on a night dive, as long as you shine your light on your hand. It is essential that you don't dazzle the other divers by shining the light into their eyes. Before signaling, you must get your buddy's attention by shaking your light backwards and forwards, or alternating light and dark. Remember that you should never switch off your light. There is always the risk that it will stay off. To get the off effect when signaling, just cover the glass with your hand. It is also possible to make signals with your dive light. Drawing a circle with your light near your buddy means OK. A horizontal oscillation is usually used to signal no or something wrong. Naturally, you can add other signals. When diving from the shore, two lights can help you find the exit point. Their alignment enables you to identify the right direction to swim in towards the shore. Just place the two recognizable lights at different heights and align them with the exit point. Making the dive. If you know the site well, the best time to make the dive is when it is pitch black, when nocturnal animals are most active. If, however, you are not familiar with the site you are going to dive, it is best to enter the water at sunset, when there is still some visibility. Using a large-sized boat makes this type of diving easier and safer. It is also undoubtedly more comfortable. Don't use new equipment for the first time. Only use equipment that you are familiar with. Prepare your equipment well in advance, before it gets dark and you are forced to use your light. Use a low-intensity light while you put on your equipment, so you don't ruin your night vision. Before getting into the water, make the usual buddy check. Make sure that there are no dangling accessories that could get snagged on the seabed. Your dive light should be switched on just as you enter the water, so if you happen to drop it, it will be easy to see. On the other hand, don't switch strobe lights on out of the water because they could dazzle someone. Before getting in, carefully check the surface of the water to avoid falling on some floating object, or worse still, another diver. As soon as you are in the water, move to the descent line. Using a line for the descent will prevent you from feeling disorientated and enable you to control your buoyancy better. Once you are under the water, you or the instructor will switch on the strobe light, attaching it to the line so that you will be able to see it easily on your return. You will make a guided dive, dedicated only to identifying the nocturnal creatures you encounter. Take care not to blind your buddy by pointing your light in their face. At night, it is easier to touch something that stings by mistake, so take care. In case of separation from your buddy, it is usually easier to find them than during the day because you can use your light to locate the position. If you can't see them, try covering the light by putting your hand over the glass. This will make it easier to see the flashes of the other lights. Turn around in a complete circle and try to see a glow of light. If you can't see anything, try turning around while being a lighthouse so the others can find you. If this doesn't work within the time established in the briefing, ascend to the surface and meet up with your buddy. In fact, if you both follow these procedures, you will automatically meet up on the surface. On the ascent, pay attention to the alarms of your dive computer and ascend slowly using the line. Happy diving!